So we can solve for position, velocity, and acceleration of four-bar mechanisms. And a question might be, well, why? Well, I'll explain to you why here. One measure of goodness of a mechanism is transmission angle. And transmission angle is defined as the angle between the output link and the coupler. Okay. More specifically, it's the absolute value of the acute angle of the intersection of those two links. It varies over the range of motion of a linkage. Something to keep in mind up to this point is that 90 degrees is optimal, and it'll make sense on the next slide presentation, or slide, and 45 to 135 degrees is a rule of thumb for all angles of rotation within a four-bar mechanism. So what does this mean here? So really what our transmission angle is the angle between this coupler here and this output link. So this is our transmission angle, mu. And I told you that 90 degrees is ideal, right? And we'd like to keep it between 45 and 135. So let me explain to you why 90 degrees is ideal. So if I've got an output link like this, and I've got a coupler that sits here, okay? I won't draw the input crank, but essentially what is happening here is that my coupler can provide a force in this direction, okay? Now, I want to use this output link for something, right? So I want to use this force for something. So if I think about it from a power perspective, the power of this output link is going to be torque times the omega of the output, okay? So this is output power, okay? This is maximized when this angle, okay, the acute angle between the coupler and the output is 90 degrees. You think about it from X and Y components of force, and the most useful force comes when this is 90 degrees. An extreme case, I've got my output link here. It's going to rotate about a joint here, and let's just assume that my coupler link is at a very sharp angle, right? So my force can go something like this in this direction. This angle mu is small. So most of the force goes into stretching or trying to tear apart this output link, and very little of the force goes into useful power, okay? So 90 is ideal. We'd like to keep it 45 to 135. If you go back to ME3010, then you realize at this point the sines and cosines begin to work against you, and you end up with components of the force pulling or pushing along this output link as opposed to rotating the output link. So that's transmission angle. So transmission angle is a measure of goodness of the output power. Okay. Talk about mechanical advantage. Again, this is related to transmission angle. Mechanical advantage is output force to input force. Okay. We've got output force is torque of the output over radius of the output, and input force is torque of the input over radius of the input. So we can relate our mechanical advantage to something that looks like torque out divided by torque in times R in over R out. We'd like to maximize this mechanical advantage. If we look at it from a velocity ratio perspective, we've got omega out over omega in. Now, I've provided you with the vector loop equations to get both of these guys, okay? So you can solve for both of these. In many cases, omega 2 will be in, and then we're looking at omega 4 to be out. We're interested in this because power is torque times omega. I told you, power in is torque times omega. We'll assume 100% efficiency here, which means there's no power loss in the joint, so there's no friction. So we can look and solve from our velocity analysis to determine input and output. Okay. We go back here a second. We can measure this graphically. You can compute this as well. So if you know theta 3 and you know theta 4, we can find what the value of this mu is over the entire expression. So you might end up with a Excel expression that looks something like this. Theta 2 will go from 0 to say 360 degrees by 1 degree increments. I can solve for theta 3, 1 and theta 4, 1. I can solve for theta 3, 2 and theta 4, 2. And finally, I can solve for transmission angle. I would encourage you to do this in your MATLAB code. You should do it for your project. This is an appropriate analysis. If you have any questions, please let me know. I'm more than happy to answer them for you.